All right, today we're jumping into a really fascinating story about national ambition. But this isn't just about building a new factory or a lab. It's about how an entire country is strategically drawing up the blueprints for its future in some of the most critical technologies on Earth. Let's get into it.
So, how do you build a future? I mean, it's a huge question, right? It sounds kind of philosophical, doesn't it? But for a nation like India, this is actually a very practical problem. How do you go from just having an idea to becoming a real global leader in the fields that are going to define the next 100 years? That's what we're going to unpack.
And you know what? Here's the answer, laid right out for us. It's not about some single magic bullet. It's a comprehensive blueprint, a master plan, really. And it's built on three main pillars: big national missions, developing the entire ecosystem, and deep advanced research. This is the foundation for everything else we're about to talk about.
Okay, so let's start with that blueprint. The first thing to get is that this is not about one single project. We're talking about the deliberate creation of a whole interconnected ecosystem where universities, government, private companies, and global partners all work together. And just so we're on the same page, semiconductors are the brains in all our electronics, while superconductors are that next-level stuff, materials that conduct electricity with zero resistance. Absolutely key for future tech.
And the goal here? Well, it is incredibly ambitious. The aim is to make India a central hub for the technologies that are going to power our future, everything from AI to quantum computing. In a world with pretty fragile supply chains, this is about more than just economics. It's about technological independence. It's about playing a leading role, not just a supporting one.
Every huge ambition needs a rock-solid foundation. But in the 21st century, that foundation isn't built with concrete and steel. It's built with two key ingredients: serious brainpower and just massive, massive computational muscle. This right here, this is the intellectual engine room. We're talking about world-renowned institutions, the IITs, the IISc, and the whole network of CSIR labs. This is where the breakthroughs happen. They're the source of all the talent and the fundamental research that drives everything else.
So you have all these brilliant minds. What do you give them? You give them power. And that's where this number comes in: 40 petaflops. That's the sheer computational firepower being made available by India's National Supercomputing Mission. To put that in perspective for you, that's 40 times quadrillion calculations every single second. It is a staggering amount of processing power.
Right, and this isn't just a big number to brag about. This kind of power lets researchers run these unbelievably complex simulations. They can model new materials and understand the fundamental physics of superconductors without spending years and years on physical trial and error. It just dramatically speeds up the whole pace of discovery.
But, brilliant research can sometimes get stuck in the lab. To turn those incredible ideas into actual products that you can hold in your hand, you need an engine. And in India's case, that engine is a powerful combination of focused government missions and raw industrial might.
At the very heart of the government strategy is the India Semiconductor Mission, or the ISM. The best way to think of it is as the conductor of this whole high-tech symphony. It's the central group with one job: build the entire semiconductor and display ecosystem piece by piece from the ground up.
And the government is putting some very serious money behind this vision. We're talking about an investment of 4,500 crore rupees, which is over $500 million US, all targeted specifically at modernizing key facilities.
Now, that funding isn't just a number on a spreadsheet. It has a direct, tangible target. It's for upgrading critical infrastructure, like the SCL Mohali fabrication plant, or FAB for short. These fabs are incredibly complex and expensive facilities where the actual silicon chips get made. So this investment is about building real domestic manufacturing capability. It's a huge step.
And this slide just perfectly illustrates the public-private partnership that's going on. You have the government, through the ISM, setting the vision and giving it that initial push with funding. And then you have industry giants, like the powerful alliance between the Tata Group and Intel, stepping in to provide what the government can't: massive manufacturing scale, global supply chain connections, and deep commercial expertise. They really are two sides of the same coin.
So, let's recap. We have the brains, we have the computing power, and we have the industrial engine. Where does all of this lead? Well, it leads right here, to the absolute cutting edge of technology. We're talking about moving from building the foundation to making some serious quantum leaps, both figuratively and, literally. This is the pathway from a brilliant idea to a revolutionary product. This innovation pipeline is so crucial because it connects all the dots. It makes sure that breakthroughs in advanced research actually lead to homegrown processors. Those processors then get scaled up for commercial production with government support, and finally, they get deployed in real-world applications. It's a complete end-to-end system.
And this isn't just a theory. Here's a concrete example of success. QPII, which is an Indian startup, has developed the Kaveri, a 64-qubit superconducting quantum processor. In the quantum computing world, the more qubits you have, the more powerful the computer. So this is a huge deal. It is a tangible piece of hardware that proves there's an indigenous capability at the absolute frontier of computing. Okay, let's pull all of these threads together. This entire domestic ecosystem, the research, the industry, the quantum breakthroughs, it's not being built in a vacuum. It's being designed from the ground up to compete as a major player on the global stage.
This slide just puts it all together beautifully. You can see how each piece we've discussed fits into this larger system. You've got the raw computing power from the Supercomputing Mission, the government strategy through the SISM, the industrial might of partners like Tata Intel, the research brains at the IITs and IISc, that quantum edge from innovators like QPII, and of course the global reach through international collaborations. It is a complete, self-reinforcing system. So when you combine all of these elements, what you get is more than just a domestic industry. You get a system that truly embodies innovation, resilience against those global supply chain shocks, and, maybe most importantly, the ability to compete with anyone in the world.
And that leaves us with one final fascinating question to think about. As other nations are grappling with how to compete in this high-tech race, is India creating the definitive blueprint for what it means to be a tech leader in the 21st century? It's a powerful strategy, and you can be sure the world is watching.